Okay, in this video, it might be a little long. We're going to be going over percent composition and empirical molecular formulas. This is like the hardest part on the test and the hardest part of this unit, but we are going to be using it all year, so you do have to know how to solve these problems. The percent composition is a little easy, so the first thing you need to do for percent composition is understand what it is. And so if you look at this formula here, it is H2CO. I'm basically saying if I had that atom in my hand right now, so I have that molecule, or that compound, and I want to know what percent is hydrogen, what percent would be carbon, and what percent would be oxygen. And so I've shown you a little graph here, and so I would see 51.41% of this is oxygen. But how did we get these numbers? Okay, and you know, how did I get these percents? It's pretty simple. You just do the part divided by the whole times 100. Anytime we're dealing with percent, we always multiply times 100. So I find the molar mass of the whole entire compound. So I'm going to get the whole molar mass of this. And let's say I want to know just what carbon is. So I'll put carbon at the top divided by the total, the whole molar mass times 100, and that'll give me the percent. So let's look at some easy practice problems, and then we'll take it up a notch. So here go some easy ones. So they want to calculate the percent of hydrogen in water. Well, the formula of water I know is H2O. And so I need to first get the whole molar mass. So use the periodic table that I have up there. 1.008 times 2 plus oxygen, which is 16, and that gives me 18.016 grams per mole. Okay? And so to do the percent composition, I need the part divided by the whole times 100. So they want to know hydrogen, so just this part. There are 2 hydrogens, so I need to make sure I multiply it times 2. So it's going to be 1.008 times 2 divided by the whole, which is 18.016 times 100, because I'm looking for a percent. Equals, and I got 11.19%. I always like to put my percents in 2 decimal places. It just makes it a little bit easier, so I don't have to remember all these rules. Just 2 decimal places and you'll be good. Unless it's a small percent. And so that would be my answer. So if I have a water molecule in my hand, that water molecule has 2 hydrogens, and they are only 11.19% of the actual mass of the water molecule. All right, next I have ammonia. So ammonia is NH3. It's one of those that we're going to be using quite often, so just start memorizing the formula. Get the whole molar mass. If I do it, the whole molar mass should be 17.34 grams per mole. They want to know just the nitrogen, so there's only one nitrogen, so it'll be 14.01 times 1, or you can just leave it, divided by the whole, 17.034. I'm looking for a percent, so times 100%, and it is equal to 82.25%. So in that molecule, nitrogen is 82% of that molecule, so it's a very large percentage. And then the last one, calculate the percent composition of nitrogen in a different formula, nitrogen dioxide. That would be NO2, because it says dioxide, but we'll get into naming later. We won't cover that until we get closer to chemical reactions. But nonetheless, to get a formula, I have 14.01 plus 16.00 times 2. I got 46.01. As the molar mass, and so they want to know just the nitrogen, so that is 14.01. There's only one of them, so I don't need to multiply it. Divided by 46.01 times 100%, and I got 30.45%. And so notice, even though I'm finding nitrogen in both of these, it just depends how big the molecule is and how many nitrogens are actually in it to tell me what the percent is. All right, this is where things get real. So, from those percentages, if you work in a pharmaceutical company or you work with researching in a chemistry lab, this is pretty much the majority of what they do. So a friend of mine is a pharmaceutical rep over in, I think she lives in Washington now. But what she does is she does tests, and so she gets this information, and she's testing different chemicals, kind of like, chemicals make you feel better or whatever. She gets a list of how much is in each of the compounds. So chlorine, she can see that there's 71.65% of chlorine in this molecule. 24.27% of it is carbon. 4.07% of it is hydrogen. And so from that, she has to calculate and find a formula for it, and then she'll be able to test other experiments by drawing out structures and organic chemistry. But we're not in that class. We're just in AP Chem. So there are 4 steps. I changed the steps from the notes that you have, so I would make these changes. These changes are much better, and it's a lot more friendlier on what you're actually supposed to do. So step 1. What is an empirical formula? An empirical formula is basically the simplest whole number ratio atoms in a compound. So, what's the simplest formula for this giant molecule? If it repeats, what is that repeating formula? And so I'm looking for the simplest form. We're going to get into the harder form in a second, but for now, it's just the simplest form. Step 1. You need to first determine how much is present in the compound. How many grams of each of these you actually have. So I don't have grams here, though. I have percents. So imagine if I have 100 grams, because these are percents. If I had 100 grams of this substance, whatever it is, 71.65 grams of it would be chlorine. 24.27 grams would be carbon. And 4.07 grams would be hydrogen. So I'm going to change all these percents into grams. So it's basically like I have 100 grams of it in front of me. From there, I'm able to do some calculations now. Step 2, I'm going to convert all of them to moles by dividing by the molar mass. So chlorine is just Cl, so I'm going to divide it by the molar mass, because I want to change it to moles. Okay, I'm converting it to moles. 1 mole is equal to the molar mass. If you look on the periodic table, chlorine is 35.45. And I'm going to do that to each of them. Carbon, I want to change it to moles, so grams, I'm going to convert it to moles. 1 mole is equal to 12.01 grams. And same thing with hydrogen. Hydrogen would be 1.008 grams, and I'm trying to change it to moles. I'm going to plug all these into the calculators. The less you round, the better. If you round too much, your numbers might get a little funky, so just make sure when you're doing this, try not to round too much. I like to go 4 decimal places in, unless it's a small number. Or 4 sig figs, I'm sorry. 4 or 5 sig figs will be good. So chlorine, if I plug this in correctly, I got 2.0212. And you can write moles, or I can just write that down. I'll write moles. On this one, I got 2.0208. And the last one, I got 4.0377. Okay, so I'm done with step 2. All right, step 3 now. I'll change colors. Step 3, we're going to divide each of the answers by the smallest number of moles. So looking at this one is the smallest one of them all. So I'm going to divide each of them by that number, 2.0208, 2.0208, 2.0208. And then here's where I'll round. Don't round too much, but round enough to get either a whole number or a half a number. For example, if I plug this into the calculator, I get about 1. This is also about 1. And this is about 2. And so, if I'm looking for my formula, here is how many I have of each of the molecules. Chlorine, it says I have 1 chlorine. I don't need to put a 1 because a 1 is always implied. For carbon, it says I have 1 carbon, so I'll just put a C. And for hydrogen, it says I have 2 hydrogens, so I'm going to put a 2 here. And this right here is my empirical formula. And that's how I'll be able to tell what's the formula of my compound. Okay? Let's try another together. Yeah, just one more together. All right, so this one, you got to set it up just like how I had that last problem. I did it for you, but I want you to try doing this one. So we have carbon, which is 57.14%, but I'm going to change it to grams. Then I have hydrogen, which is 6.16 grams. Then I have nitrogen, which is 9.52 grams. And then oxygen, which is 27.18 grams. Okay. Step 2, convert them all to moles. So I'm going to take them, and this would be 12.01 grams, and I'm going to change it to moles. This would be 1.008 grams, 1 mole. This would be 14.01 grams, 1 mole. And this would be 16.00 grams equals 1 mole. I'm going to plug them all in. Try not to round too much. I got, for my answers, 4.758 moles, 6.1111 moles, 0.6795 moles, and 1.6988 moles. All right, that's step 1, step 2. Step 3, divide by the smallest number. So I'm just going to put a line. I like to do that because it's a lot easier. Okay, that's a terrible line. I'm going to divide all these numbers by the smallest one, which was 0.6795. So right here, put the numbers again. So if I divide this first one by that number, I got, if I round, I get about 7. This one I get about 9. This one I get about 1. I want you to put this one into the calculator. 1.6988 divided by 0.6795. If you do it, you're not going to get a whole number, and you're not going to get close to a whole number. It's actually closer to 2.5. It's right in the middle. You can't round a 2.5. So since it's 2.5, I have to change it into a whole number. And so remember, I'm trying to get the simplest version. So what would be the easiest number to multiply this by to get a whole number? It should be 2. So I'm going to multiply this times 2, this times 2, this times 2, and this times 2. That's going to equal 14, 18, 2, and this will equal 5. And now that I have all whole numbers, I now have an empirical formula. Carbon was my first one, so C has 14. So 14. Hydrogen was the next one. Hydrogen has 18. Nitrogen was the next one. Nitrogen has 2. And oxygen is the last one, and it has 5. And there is my empirical formula. Okay, so if I don't get a whole number here, you need to start multiplying times 2 to get a whole number. Sometimes you'll have to multiply times 3. It just depends on the number they give you. If it's close to a whole number, round it. Like this was close to 7, so I'm just going to say 7. All right, this question I'm going to do last. This is not mandatory. This is the extra credit on your test. This is already the question I'm going to ask you on the extra credit. It'll be worth 10 points, so it's a pretty difficult question, so that's why I'm going to do this last. You don't have to do this problem. You can just skip that part of the video at the end and you can go over it. Okay? All right, so remember, empirical formula, the simple, that's not useful, simplest method. whatever. The simplest formula. Okay, that's what it means. So this is the formula N6010. I need to make it even more simple. I can divide both of these numbers by 2, and I will get N305. And that's the simplest version I can get it to. So this right here would be the empirical formula. This one up here, the more complex ones, N6010, this is called a molecular formula. So a molecular formula is the exact formula of the molecule. So you know how I said if I have a big molecule and it breaks up into empirical formulas, the molecular formula would be the entire thing. So it would be like the entire molecule. What is the formula of this giant molecule? That's what we need to calculate. Blah, 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 blah. Okay, so this right here would be an empirical formula because this is the simplest version. And if I multiply times 2, I would get a molecular formula. This would be a type of molecular formula. The molar mass would also multiply times 2 because I have twice as many molecules. So knowing that, I should be able to go and get a molecular formula if I know what the empirical formula is. So in order to do that, I'm going to need to multiply the empirical formula, then I get the molar mass, and then I'm going to divide the empirical formula's molar mass by the molar mass of the compound. So let's just try looking at a problem. So many compounds have the empirical formula of CH2O. Letter A has a molar mass of this one, letter B, and letter C. Determine the molecular formula for each. So step 1. I'm going to get the molar mass of the empirical formula, CH2O. And that's going to equal 30.026. Yeah, that's what I got. Grams per mole. And there's my empirical formula molar mass. So letter A, it has a molecular formula of 30.0 grams per mole. So I'm going to put that on the top, 30.0 grams per mole, divided by the empirical formula, 0.026 grams per mole. And if I do that, I get about 1. So that's telling me that this molecular formula for letter A is 1 times bigger than the empirical formula. So if I take CH2O and I multiply all those little subscripts by 1, I'll get the exact same formula. And this is the molecular formula for letter A. I'll put a little line here just so I know it's on the formula. Letter B, same thing. This time I have a molar mass of 60 grams per mole. Divide by the same molar mass of the empirical formula. And I will get about 2. So that means that the empirical formula, all these little subscripts, I'm going to multiply them all by 2. And I will get C2H4O2. And this is going to be the molecular formula for letter B. Letter C, 180 grams per mole. Divided by that, 30.026 grams per mole. I get about 6. So again, same formula, all times 6. And I'll get C6H12O6, or glucose, and that is also the molecular formula. Okay, try pausing the video and try doing this one on your own. Okay, if you did this one on your own, then you should be good. ClCH2. If I get the molar mass, I got 49.469 grams per mole. They want to know what's the molecular formula. Here's the big molar mass, so I'm going to put 98.96 divided by 49.469. That equals about 2. So the molecular formula is Cl2C2H4. And that would be the answer. The more difficult part is when you have to do both, okay? And so in this one, it's asking what is the empirical and the molecular formula. So you have to set up and do the empirical formula like we did earlier, where we have to list them out and then start solving. So phosphorus is going to be 43.64%, or grams, I'm sorry, because I'm going to change it to grams. Oxygen is going to be 56.36 grams. And so this one would be 30.97 grams. I'm going to change it to moles. This one would be 16 grams. I'm going to change it to moles. I got 1.4091. This one is 3.5225. Divide by the smallest number. This equals 1. The bottom one is about 2.5. It was too far in the middle to round. So I'm going to multiply both of these by 2, and I'm going to get, on the top I'll get 2, and at the bottom I get 5. So my empirical formula is going to be P2O5. That's the answer to this one. Now they want to know what's the molecular formula, so I need to know molar masses. P2O5. And I need to get the molar mass. If I put in the calculator correctly, I got 141.94 grams per mole. It tells me that the big molar mass is 283.88, so 283.88 divided by 141.94 is about 2. So my molecular formula is twice as big as the empirical formula. So the molecular formula is going to be P4O10. Try doing this one on your own. I'll put the answers off to the side. If you got them, then you can skip the rest of the video unless you want to watch the extra credit, and you're good. If you did not get it, then play the video and figure out how I did it. For the empirical formula, for this one, I got P in Cl2. And so for the molecular formula, then I got P5 N5 O10. So if you got that, you can skip and you're done unless you want to watch the extra credit. If you didn't get it, then watch the video. Phosphorus, nitrogen, and chlorine. They're all percent, so I'll just change them to grams. Gosh, so many emails. Oh my goodness, what am I doing? Okay. Let's see, 61.2 grams. Okay, divide by the molar mass to change them all to moles. If I do that, I got 0.8621. 0.8572. And 1.726. Divide them all by the smallest number, 0.8572. Top one I get about 1, 1, 2. So the empirical formula is P in Cl2. They're not even looking for empirical formula, so they just want to know what's the molecular formula. So the molar mass of this is 115.88. And so, to get a molecular formula, I'm going to do 580, because that's the big molar mass. 15.88 grams per mole. And I get about, how much do I get? About 5. And so, my molecular formula is 5 times bigger than the empirical, and so I'll get P5, N5, and Cl there's 2, so times 5 would give me 10, so Cl 10. That would be the correct answer right there. Alright, so to the extra credit question. Again, this is optional. This is just if you want to get that extra credit points at the end on the test. Alright, so here we have some real problem. Alright, so on this one it says, suppose a substance has been prepared that is composed of carbon, hydrogen, and nitrogen. When 0.1156 grams of this compound, so that compound there that has those 3 elements, is reacted with oxygen, I get 0.1638 grams of CO2, 0.1676 grams of water is collected. Assume all carbon is converted to CO2. I started with how much carbon, and what is the empirical formula of the compound. This is a very complex problem, but it is the same problem that we've been doing. So here first, here's a formula of what they're trying to say. I have some formula of CX, HY, NZ. And I'm trying to figure out how much of each of them I have because I'm looking for an empirical formula. And it says it's reacting with oxygen. And I made CO2, and I made some water. Well, the nitrogen has to go somewhere, so I'm going to make something that has nitrogen in it. I don't know what it is, but something has nitrogen in it. So, in order to do this problem, first, what's the very first step? It's I have to figure out how much I have of each element. How much carbon, how much nitrogen, how much hydrogen. So step 1, figure out how much carbon do I have. If all of my carbon converted into CO2, then I know that I have 0.1638 grams of CO2. And all of my carbon should be in this CO2. So, with that logic, if I multiply by the percent composition, I should be able to figure out how much carbon there is in here. For example, I have 1 carbon in here, and so that's going to be 12.01 grams of carbon, divided by the whole, which is the percent composition. The whole of CO2, if I add it all up, will give me 44.01 grams. And so here is my percent composition here. Part, this is just the carbon, divided by the whole. And that's going to give me 0.04470 grams of carbon. And so here is the answer to the first question. How I started with how much carbon. So I'm going to box that one in. Okay. And so I know how much carbon I have. Good. Next one, hydrogen. How much hydrogen do I have in this compound? Well, if I assume all my hydrogen got converted as well, go to orange. Right here it tells me I have 0.1676 grams of water. So there's all my hydrogen right there. They're all right here in this formula. So I'm going to put the same thing, 0.1676 grams of water. And I need to figure out how much hydrogen is in this formula. So I'm going to multiply by 1.008. But there's 2 hydrogens, so times 2. Divided by the total, which was 18.016. Okay? If I do that, I'm again part over whole, and I'm going to get just the hydrogen, which is 0.01875 grams of hydrogen. I don't need to box this in because they didn't ask me that question on the problems. So I know how much carbon I have. I know how much hydrogen I have. Last one I need to figure out is how much nitrogen do I have? Well, they didn't give me the formula of nitrogen because I still have a question mark here. I have no idea what this formula is. But they did tell me that in the beginning, I had this much of all of the compound. So, if the total is equal to 0.1156 grams, I should be able to figure out how much nitrogen I have. For example, I have the total right there. I know I have 0.04470 grams of it is carbon. I know that the number on the side, here we go, 0.01875 grams of it is hydrogen. And so I need to figure out how many grams of it is, I'll put an X grams of nitrogen. And so this is just, I add these two problems, I add these two numbers together, and I'm going to subtract by the total. And so how many grams of nitrogen do I have? I have, if I plug it into the calculator correctly, I would have gotten X grams of nitrogen, which would equal 0.5215 grams. And so now I have all the amounts I need, and now I can solve for the empirical formula, which is the last question. So like I said, this was a pretty lengthy question. Step 1, let's list them all. So carbon, which is 0.04470 grams of carbon. I have hydrogen, which is 0.01875 grams of hydrogen. And last one, I have nitrogen, which is equal to 0.5215 grams of nitrogen. Just like all the other empiricals, I'm going to divide them all by the molar mass and change it to moles. 12.01 grams equals 1 mole. This one, 1.008 grams equals 1 mole. And then the last one, 14.01 grams is equal to 1 mole. I'm going to plug them all in, and I'm going to get numbers. This one is 0.003722. This one is 0.01860. And this last one, 0.003722. I'm going to divide them all by the smallest value, which was 0.003722. I will get, for the top, I'll get a 1. For this one, I'll get 5. For this one, I'll get 1. And so we have found our answer. For the empirical formula, it is going to be 1 carbon, 5 hydrogens, and 1 nitrogen. And that would give you the full points for this problem.